Hi guys, today I will show you my process how to solder the main board for the PDA, and we will go through what we need. And we need the boards. You can get the manufacturing data on GitHub. There are two boards, this little one for the LCD and this big one for everything else. This is how the finished product will look like. The board is inside. So, what we will need? First, we will need soldering station. I've got this one. It's not great, but it works. You need somewhat clean tip, clean and fine. And to clean it, you just don't use this. It's crap. Buy some like this copper wool. It's used for dishwashing. Put it inside like jar and then you clean your tip like this. And it works like charm. And it's like a buck. Then we will need we will use some flux. I have this Amtech. Come on, focus. Come on. I have this nice Amtech flux. I got it because I saw some videos with Louis Rossmann and he was using it and I was like, wow, this is like really good. It's no clean soldering flux, so you don't need to clean it up and your product will work anyway, which is great. Then we will need some solder. I've got like this really thin one, and for the larger jobs you need something bigger, like this 0.6 millimeters. And if you screw up something, you need this like solder wick. This one is really cheap, but combined with this flux it works like charm. For the optical inspection you need like this, like some sort of magnifying glass, or if you have a microscope then you are a lucky bastard. Something like this is useful. It looks really cheap, but if you like tighten it with pliers and never move it, it works pretty well. Well, for the testing you will need some, like, this is really cheap multimeter, but you need just something that can measure voltage and current, and this one does it, so it's good. To clean the board you would need like isopropyl alcohol or something, but like regular alcohol just works well enough. Next thing is just like big bag of parts that will go on the board. So I have it and that's good. And lastly you need some, like a chocolate treat to reward yourself with after you finish soldering the board. Also I have a schematics here and this box with some tweezers and X-Acto knife and some screwdrivers. As always with soldering, we will start with the surface mount components, and we will start from the shortest ones to the tallest ones. Okay, after a bit of fuffery with the lights, I ended up with something you can hopefully see, and I can hopefully see. So we will put a tiny bit of flux to the USB port. We will look at it carefully to see if it's aligned, and we want the small pins to be aligned, not the big ones. The big ones will align itself. Okay, and then hopefully we will heaten it up with the soldering iron and just solder it nicely. And now we can go to the thicker solder and solder the big holes. If you have super shaky hands, like me, try to compensate for that by resting both of your hands on the table. It helps a bit. Okay, now we will solder this one. It's a good idea to solder put solder on one of the pads and then stick the parts to it so it doesn't move with your shaky hands. So if we got it in there, we check it if it's on the spot, and then just put the soldering iron there and solder the pads. Now all we will do the fuse. And it's the same thing. Solder on one side, then check, and if it's not on the right place, then put it on the right place, and if it's good, then solder the other side of it. And resolder this one. Okay. Alright. If you are in doubt about how something should fit or how something is oriented, just check the pictures of finished boards It's much easier than check the schematics, like I just did with this diode that I'm going to solder. And also check the other side. Okay, now we will do the USB LC6, which is USB protection circuit. So and by now you know the drill. Solder one leg, check if it's okay. And as you can see, if I can do it with the hands shaky as this, you can surely do it yourself. Well, it's not perfect, but it looks good enough. Now with the tiny bit of flux, we will solder rest of the pins. It's still the same. Solder from one side, solder from the other side. Resolder. So I did solder all these passive components and these of the camera. And now I will solder those integrated circuits. Put solder on one pad. Pick the part. Put it there. And solder it. Check if it's okay. Maybe push it down a bit. And if it's okay, solder the rest of the pins. Sometimes I just like to use my fingers to hold the bigger parts. Now the inductor, and it's still the same business. Solder it on one side, and then solder it on the other side. The inductor is big, so your soldering station will need some time to heat it up. Now those two cups, and again, if there is something polarized and you don't know how it should fit, look at the pictures of the finished boards. The inspection time. I have a normal USB port, and because I finished the 3.3 volt power supply part and the battery charging part, I should test them. If you have like a lab power supply or something, you can use it, but otherwise you can just wing it and test it on the USB. So here we should see 3.3 volts and 3.36, close enough. And on the positive battery terminal we should see something like 2.4, and we see 2.3, so close enough. So far so good. And so, because it works like charm, we can finish this block. You have to be really careful with this connector, because if you solder it crooked, the battery won't fit well. So that's a bit of a challenge. I will try to solder it so you can see something, but I don't know if it will happen. Okay. Okay, it looks straight and nice. Okay, looking good. So, we have the power part finished. This maybe would be better to solder a bit later, but whatever. Okay, we will continue on the top with the SD card slot. We will solder it first because there are some passive components that would block the way to the pins. Okay, it's soldered, and we will carefully check if it's okay. If all the pins are on the pads, and they are not. So we unsolder the pin, move it a bit, and then check again. And now it fits. Now it fits well. So we can solder the rest of them. And now I will do all of those passive components of the camera. Next part that's a bit harder to solder is the real-time clock crystal. It looks like this. Oh. Put some solder on one of the pins. Align. Okay. I think it's good. And it looks perfect. Now for the main clock crystal. It's in much bigger package, so it's really easy to solder it. But also, because the package is so big, you need to position it in between these lines on the solder mask, otherwise it won't fit in the case. And solder it down. Okay, now I have all the surface mounts on this side, except for the microcontroller. So we will do it now. But before, maybe we should check the voltage rails if there is no short on any of those new components. So we will check the positive battery terminal, and it's okay. We will check the 3.3 volts, and it's okay, so no shorts there. And we will check the voltage reference, which is 3.3, so that doesn't work. Interesting. there's like some really interesting grounding issue on the board. So because this should be grounded on the other side, and it is. And if it's connected, that's some PCB bug, but hopefully when we solder the microcontroller, it will connect through the ground connects inside it. I will fix it in the next board revision. So the board is mostly working, and now we will solder the microcontroller itself. So this is it, and like always we will put a tiny bit of solder on one pad, orient the microcontroller, and this dot on the microcontroller should be where this line on the, yeah, you cannot see it. Basically, yes, here there is a longer line that indicates pin 1. So now it's all about carefully positioning it so all the pins are on their pads, and then we'll touch up the one pin. Okay, I messed it up a bit, but that's okay for now. And now we must check it if it's okay. If all the pins are on their pads. So I will use my magnifying glass and check it. And it looks good. So now we solder the pin that's opposite to the previous one. Okay, I moved it a bit, so I'll move it back. That looks good. Now I don't know if it looks good, but it looks mostly good. But I will check it again. Yes, it fits. And now we will use the flux and solder it there for good. If you are unsure about the orientation of any part, you can always check the pictures. And now we will just solder all the pins. Like this. Start on a different corner than you soldered before, so you don't unsolder it. Now just go over it, use the power of this miraculous flux. If there are solder bridges, you just push them away. Okay, this one is a bit stubborn, but eventually it will surely go away. Okay, there is a tiny solder bridge, but you can use like the solder wick and wick it away. Looks okay. And if it bridges some pins, you just wick it away and pull it away with your soldering iron. Now again, inspection. And we have a few bridges on this side, so use some flux. And clean them out. I wasn't sure about some pins on this side, so I'll touch them up again. So that's the microcontroller soldered. Back to the interesting PCB bug. I have a multimeter in a continuity mode, and we will check if it's continue from here to the ground, and now it is. So now we will check if the microcontroller is working. So plug it in, and we are looking for the core voltage. And again we have 3.3, and we are looking for the VCAP, and that should be 1.2. I don't remember, but it should be lower than 3.3. That's okay. Okay, we are finished with the SMD stuff, and for the through hole we are going to the ugly hack territory. So what's the problem? The problem is that I use THT buttons, and as you can see, if you push the button there, the pins go on the other side, but on the other side there is this connector, and that doesn't fit. And also, if it fits, the button doesn't fit. So there is a simple solution to it, and those are like clippers, and clip the pins so it solders flat in this area. So I'm gonna do it, and I'm gonna solder those buttons. So I have it done. I have all the buttons clipped, and they are flush in this area. And I also cut the pins on the expansion connector so it fits. Now you first have to solder the buttons, because when the connector is here, you can't access them. Don't use too much of a solder because you need them to lay flat, but also they have to be pushed all the way to the PCB on the other side. Otherwise the case doesn't fit. Okay, they look nice and flat on the board. So now the connector. And now it's time to solder it. And again, solder one pin, pull it out, the connector, and so it's nice and straight, and then solder the rest of it. For the LEDs, it's best to have a part of the case for the SDA, and put the board inside. And now you can pick the LED. And again, if you are unsure about the orientation of it, look at the pictures. And then you need to match its position. And then bend the pins. It's not like the best tweezers to do it, but no, that's the wrong way. This way. And you bend it. Cut the pins a bit. So you still have some pins to go if it's wrong, the position is wrong. Plug it in, pull the board in, and it looks like it fits nicely. So we can solder it down. Okay, as you can see, the LED fits through the case. And we solder one pin, adjust the position of the LED, and solder the other one. The charging LED is a bit more tricky because you have to bend the legs so it fits well. Okay, somewhat good. It's too long. So we will straighten the legs and bend it again. Now is also the right time to put the heat shrink on the LED. And with the heat shrink we can trim the legs. Check it if it fits. And yeah, that's close enough. So we can solder it. the legs on the LED are long, so we can adjust its position later. And we can also check if the LED works, because now without battery it should light up, and it lights up. Now we solder the expansion and programming connector, and the board and the system board is finished. Now the connectors. And the way we will do it is like this. I soldered the expansion connector mostly in the same way. And so the main board is finished. We will move to the LCD board, which is this tiny board that has only the flat flex connector. The LCD connector board is here because of volatility of the LCD market. In the future, Chinese guys will run out of the type of LCDs that I use, and that would mean I need only to change the LCD board, and I can keep the system board. That's the benefit. And what's the bad part of it is that those two boards need to be soldered together. But it's not too hard to do. First thing is to align them, and for that I have my special alignment tool, which is just normal pin that fits through the hole, and you fit it through both of the boards. Now fit one on the opposite side, flux it a bit, and just put the soldering iron on one hole and push the solder inside it. Keep it aligned, and voila, it gets soldered together. Okay, and after that you can pull out the alignment tools and solder the rest of the holes. Okay, that's it. We will check the other side. And maybe add a bit of solder from the other side. It's not the prettiest, but it works. And speaking of working, we will try it. Plug in the SD card. First we will just flash the firmware inside, and that's done by connecting the programming connector to the ST-Link programmer. Then let it flash the firmware, and it throws an error because I'm stupid and I did not connect it to power. So now it should work. Okay. And it's flashing. And if all goes well, we should have a blinking light. And we did have a blinking light. If I reset it, it blinks twice as a sign of booting. Okay, so we have a firmware. Now we will plug in the LCD. Okay, looks good. And now plug in the power again. And nothing. That's not good. The LCD is not initializing. Okay, I fixed the bad solder joint on the flat flex connector. And now the second try, and it sort of works. This usually means some mess in the flex. No, still. Okay, I touched up the flex a bit and it shows error, but it shouldn't. The card is here. So maybe I just did a bit. Maybe the file system got a bit broken. So it turned out that the card was bad. And the PDA is working, hopefully. And yes, it works like charm. I'll try the buttons. Left, down, up, right. B, it switches off, it switches on. Backlight control works. Okay. it's time for me to have my treat.